Welcome to BKW Physics. I'm Mr. McConnelly, and today we're going to do a demonstration. This is a Jacob's Ladder is the name of this. And the first thing I want the folks in the room to try to look at or identify is ignoring the wooden part here and just looking at this thing here, this black box. Do you recognize it? Have you seen it before? Where? It's close. It does kind of look like that, but that's not what this one's from. Okay, good guess. Anyone else seen it in your house? Not everyone has this in their house, but a lot of people do. In your basement? Like this? No one's seen it. That's alright. I didn't really expect people would have seen it, but it's connected to, if you have an oil furnace in your house, which some of you don't, but if you have an oil furnace, these things help ignite the oil and burn it. They can, yeah, or nearby. There could be like a reset button. So this is actually called transformer. And what it does is when you give it normal electricity, we'll call this for today since it's day one in physics, just to be clear for the video, no one knows anything. So for day one, normal electricity, which comes out of an outlet, which, do you know how much voltage that has? 12. Nope, 12 would be like a car. Way higher number. Way higher. 120. Okay? So like 120 volts comes in this way. And then this magical transforming device, because it's called a transformer, does something to this voltage. And in fact, it's written right on here. This one takes a primary voltage of 120 and converts it to a secondary voltage, where it comes out of here, of 10,000 volts. Okay? That'll set you back a little bit. That being said, this is why I don't want you guys to even think about getting any closer than you are. Okay, don't reach out, don't be like, ooh, when the demo starts.
Flashing that.
Yeah, just stay back. It is unsafe for you to be close. Now, what I'm going to do with this, I'll turn it so everybody can see, including the video. I'm going to take one wire and put it to this side. I'm going to take another wire and I'm going to put it to this side. And that's going to take the electricity, that 10,000 volts. It's going to bring it around, and it's going to connect it to these two pieces of metal. So what do you predict, science predict, what do you believe will happen here? Arc back and forth, a little lightning bolt in there. Anyone ever seen this demo before? Yeah? Reduce the illumination to nominal levels, please. You knew the signal. Alright, here we go. Can you see it in the video? Look pretty clear?
Yep.
Alright. So, let's, I don't really want to touch it. I'll just stay at this distance, tuck my tie in. What do you see? Just observations. It moves up. That is key, and we'll talk about that more. What else do you see? Light. What color? Blue, purple, orange, I heard. What about right where it touches the metal? Can you see your clothes?
Yes.
It's just spark like white almost, right? On a relative scale, which colors indicate which one has the most heat? Which color is the hottest? White. So right, it would make sense, right, when it's near the metal, it's the hottest. As it gets towards the middle, the oranges and the yellows, that's not very hot. That's like a campfire hot. So you have different heat levels indicated by the colors. Back to the other thing. It's going up. It's going up. Why? Let me unplug it for a second so maybe I can turn it and people can kind of glance at it. What do you see with the two pieces of metal? Okay, two pieces of metal are like this. Does that have anything to do why it goes up? Or do you think that we say one person just said, nah, it just stretches it. So if I put them parallel like this, perfectly parallel, what do you think it would do? Same thing? Connect the two ideas. You said colors indicate heat. it's rising. What do you know about heat? Heat rises. So one of the main factors here of why this moves up is that heat rises. So this electricity starts jumping across there. Electrons, when they're moving in the air like that's real hot, so that heat rises up. So if that's true, I should be able to keep it down by cooling it. So watch this. I will. I'm just going to lean over the top here. And I'm blowing on it with cool air. Kind of hot here, but I blow on it with cool air, and I can actually keep it down there, and it doesn't have a chance to rise up. Another idea. Okay, so it rises up, heat rises, and then eventually it breaks. Sometimes it goes all the way to the top, sometimes, kind of depends on the air currents in the room and whatnot. Then every time it restarts, where does it restart? At the bottom. Why? Now look at, okay, it's the closest, and that's back to your other idea because it was a V. Electricity is always going to take the path of least resistance. That means if it's easiest to jump across the narrow spot, that's where it'll start. Because electricity is like you. You're lazy. I shouldn't say that in the first day. You're not necessarily lazy, but some of you might be. So, electricity is going to go to the closest point and jump there, and then the heat makes it rise. Okay, it's called a Jacob's ladder. Do you have any questions about it? For today, physics.